Okay, good morning. Welcome to
FamilyMath227a.
227a. So today, just for fun, we're going to talk about geometric series. We've talked a little bit about series before, but geez, probably not in, I don't know, 3 or 4 months.
Yeah.
What do you know about series?
Well, they usually go on forever.
Okay. That's true. What do you know about series?
Well, they sometimes have a certain pattern to them, like the Fibonacci numbers.
Okay, sometimes they have a certain pattern to them. Geometric series that we're going to talk about are series like this. 1 plus a half plus a fourth plus an eighth plus a 16th. Going on forever. What is the pattern here?
Well, you keep dividing by 2.
You keep dividing by 2. That is right. So in a geometric series, so this is a special kind of series called a geometric series. And in a geometric series, each, from one term to the next,
You multiply by something.
you always multiply by something. So this is a geometric series that we're going to start with, but this is also a geometric series. 1 plus 3 plus 9 plus 27 plus what would be the next term?
81.
81, yeah.
81.
243.
Yeah. So this is also a geometric series. Geometric series don't have to shrink, and I'll show you one other one. 1 minus 2 plus 4 minus 8. What would the next term be?
Plus 16.
Plus 16.
Well, you're multiplying by minus 2 every time.
Okay, what's the next term?
Minus 32.
Minus 32.
Plus.
So, yeah, so it doesn't have to be a positive number even that you
No.
multiply by. Okay.
Yeah.
So that's very simply what a geometric series is. And we're going to talk about what happens when you try to sum them up. Okay.
Yep.
What do you think?
It looks like this one would get closer and closer to 2.
Yeah.
Because you have a 1, and then you're adding a half, then a half of a half, then a half of a half of a half, and a half of a half of a half of a half.
What's the 100th term?
We could be here for some time.
Okay. What do you think this adds up to?
Well, since the numbers that you're adding by, well, you're getting close. If it stops, then you drop short less of 2. But if you go for infinity, you go 2.
Okay. So you both think it adds up to 2. We've talked about some techniques for summing these, and I just want to remind you of one, because this is what I want to focus on today. Do you remember the proof that 0.9999 equals 1?
Yep.
Yeah, you multiply by 10,
Yeah,
and then
so
subtract.
we say we don't know what this is. And we multiply by 10 to get 9.9999. And this is what?
It would be
10.
10.
10x. We subtract, and when we subtract, we get 9 minus 0 here, and then the rest is 0.9999 minus 0.99999, so we get 9 equals 9x, and then x equals 1. I don't want to go into why this proof works. In fact, part of why when I talk about geometric series gets to why this proof works. But this is the technique that I want to bring to geometric series. Okay? What do you think if we were going to call this series x? If this equals x, what could be an interesting thing to multiply by?
Well, you can multiply by 2.
Multiply by 2, what would we get?
You get
2
2
plus
plus 1 plus
plus
a half plus a fourth.
plus
Equals
2x.
2x. Okay, what can I do now?
Now you can subtract.
Alright.
And
well, what would you? Well, you could subtract the.
Yeah, let me better talk.
You could subtract the 1. You could subtract x. You could subtract 1 plus a half plus a fourth plus an eighth to 16th again.
Right, so I take this row minus this row. And what am I left with on the left-hand side of the equation?
Well, you're left with 2.
Okay. What happened to this 1?
Well, it got cancelled with that one.
With this one here?
so
And
you could also do it straight down. You could do 1 plus a half plus a fourth plus an eighth.
Oh, very interesting. And that would unfortunately, however, get us back to x equals this, which is
Yeah.
where we started.
But it proves that it equals 2.
In this way of subtracting, when I subtract these away, I get 2 equals x, 2x minus x.
Yeah.
Okay? So we're going to try to apply this idea to a few other series, okay?
Okay.